Assalamualaikum. Today I would like to upload my second video lecture. The topic is about catalysis. So I would like to explain what is mean by catalysis. What is a catalyst, and what actually catalysts do, and what are different kinds of catalytic reactions. So I would like to take some example from the book and explain step by step. So just starting from the definition of a catalyst. So what is a catalyst? So a catalyst is a substance that increases the rate of a chemical reaction, or in other words, a catalyst is an agent that provokes or speed up a chemical reaction but is not consumed by itself in the reaction. So just going toward catalysis. So catalysis is the process of increasing or facilitating the rate of a chemical reaction, or catalysis is actually the acceleration of a chemical reaction by a catalyst. So there is a question in every person's mind, that what actually a catalyst do to a chemical reaction. So a catalyst actually lowers the activation energy barrier for a chemical reaction. And what is meant by activation energy? So activation energy is the minimum amount of energy that must be possessed by the reactant species in order to overcome the barrier and pass on to products. So look this diagram. This is the energy on y-axis, activation energy or potential energy, and on x-axis reaction coordinates. So with these reactants, so the reactant species are here, and the reactant species must pass this activation energy barrier in order to produce the products. So without the use of a catalyst, the reactant species has to pass through a high energy barrier. And when we add a catalyst, so catalyst actually lower the barrier, and the reactant species can easily go into product. Now going toward importance of catalysis in chemistry and industry. Catalysis is important in almost all branches of chemistry. For example, in fuel production, catalysis has their role, because catalysis play their role in gasoline production by catalytic reforming. We are going to reforming in the later part of this lecture. Similarly, in the synthesis of polymers, so polymer can be synthesized with the use of catalyst, because catalyst reduces the reaction time, as well as it actually give us a good yield. For example, for the preparation of fabrics, cloths, and plastic, polymer is used. Similarly, in sulfuric acid production, and sulfuric acid is used in all chemical industries. In the same way, in ammonia production, and ammonia is used as in the production of nitrogen fertilizers. Many biological reaction are catalyzed by enzymes, or enzymes are protein, or it's a kind of biological catalyst. Example of chemical reaction that are catalyzed by a catalyst. So here I just made this list. So the first one is alkylation, nitration, second one hydrogenation, cracking, and reforming. We are going to the detail of each step. So starting from alkylation. So alkylation, this is named as Friedel-Crafts alkylation, and this is the reaction in which an alkyl group is added to an organic compound, in this case benzene ring. So benzene ring is treated with alkyl halide in the presence of catalyst. So we have alkyl group introduced into benzene ring, and HCl is produced. So catalyst is actually used as which is Lewis acid, aluminum chloride. So it is a strong electrophile. So the Lewis acid has strong affinity for the electrons, and the Lewis acid actually abstract this chloride ion from the alkyl halide, and thus it make a carbocation. and this carbocation attack on the benzene ring and it obstruct the proton, and just alkyl group is introduced, and this proton actually react with this Lewis acid, and the Lewis acid is regenerated, so thus a catalyst is regenerated and it's not used in the reaction. Similarly, another example of this kind of reaction is acylation, and this acylation is addition of acyl group from acyl chloride also taking place in the presence of the same catalyst, so the mechanism is the same for this reaction. The second one is nitration. This is an example of catalytic reaction. So nitration is actually the introduction of nitro group into an organic molecule. Particularly in this example, we are taking a benzene. So in this case, benzene is treated with a mixture of concentrated nitric acid and sulfuric acid at a temperature, so particularly ambient temperature or room temperature, because the temperature shouldn't be exceeding than 50 degrees Celsius, because we have a very uncontrolled reaction. So this benzene ring is treated with the mixture of concentrated acid and nitro group is introduced. Similarly, water is produced. So you already know that sulfuric acid is working as a strong reducing agent. So the mechanism is, in the first step, the sulfuric acid donate the proton to nitric acid, working as a reducing agent, and we have positive charge nitric acid produced, and this positive charge then dissociate reversibly and producing the water and nitronium ion, and this positive nitronium ion attack the benzene ring and obstruct the proton from the benzene ring and introduced into the benzene ring, and this proton actually react with the acid, and again the acid is regenerated, so it works as a catalyst. Our third example is hydrogenation. So hydrogenation is actually the addition of hydrogen to an unsaturated organic compound, or this is a chemical reaction between hydrogen and an unsaturated organic compound in presence of a catalyst. So catalysts usually used or nickel, palladium or platinum, etc. The simplest example of hydrogenation reaction is the reaction of hydrogen with ethylene to make ethane. So ethylene is treated with hydrogen in the presence of catalyst. So catalyst is nickel or platinum, most common. So we have ethane. The picture of how the catalyst work, or how hydrogen interact with the solid catalyst. So as you can see from this picture, is the metal surface is composed of spherical atoms, and these atoms are closely packed. So hydrogen actually and our reactant species ethylene are adsorbed on the active sites of the metal catalyst. So these are the active sites as shown here, and in this diagram also this dashed represents. So hydrogen is attached here and ethylene is attached here. So these are our reactant species. So as a result, hydrogen form interstitial hydrides. So you know already interstitial hydrides, so in which the hydrogen is attached with the metal in unequal stoichiometric ratio, and hydrogen make a bond with the metal, and the bond between hydrogen atoms are partially broken down or become weak to produce reactive hydrogen atom, which react then with ethylene and form ethane. Our fourth example is of catalytic reaction is cracking. So what is cracking? Cracking is actually the breakdown of large organic molecule such as alkane into smaller one, and that smaller one are more useful for fuel. This is done by the use of high temperature or pressure without a catalyst, or this can be done with the help of a catalyst. So using a catalyst, it requires lower temperature and pressure. Generally the reaction is represented with this equation. So this is a typical example, or represent alkyl groups, and this is ethylene group, and this is another alkyl group. So in the presence of a catalyst, this large chain organic molecule is broken down into smaller one, and these are more useful. What kind of catalyst is actually used? So a catalyst in this case is a mixture of silicon dioxide plus aluminum oxide, or this is a complex of aluminosilicate. In modern cracking reaction, zeolite is used as a catalyst. So zeolite is actually a microporous aluminosilicate complex. It's also in other form molecular sieves. So they have high surface area. Active site X is Lewis acids. So the process actually produce low molecular weight ethylene, propylene, butene, etc. Fifth topic of today's lecture is catalytic reforming. So what is mean by reforming? So reforming is actually the process which involves the restructuring or rearrangement of molecules to function better as motor fuel. Or reforming is a catalytic process in which straight chain alkanes are converted into branch form for use as a fuel. In the early catalytic reforming, aluminum oxide was used as a catalyst with a small amount of either chromium oxide or molybdenum oxide. So it worked as a catalyst. So this was an old concept, but in more modern concept, platinum is working as a good catalyst. So what actually happened in this process? A straight chain alkane, in this particular case we are taking a very general example of N-hexane. Straight chain N-hexane is converted into cyclohexane, and hydrogen is eliminated. Similarly, this straight chain this cyclohexane can be converted into benzene, and the benzene is working as a solvent for several organic synthesis, such as the preparation of styrene in this particular example given in the book. Similarly, I would like to explain a topic that is related to the catalyst, so a solid catalyst, that is sintering. So what is actually sintering? Sintering is actually the aggregation or coalescence or compacting of a catalyst as a solid mass by heat or pressure treatment. So either with the application of heat or with the application of pressure treatment, the catalyst is converted into a solid spherical mass, solid mass. So with the passage of time, the surface of the catalyst becomes inactive. So when we are using the catalyst, so its surface become inactive with the passage of time, because it is covered by carbon. So it must be regenerated by thermal treatment. So when we are doing thermal treatment, so for example, this is our catalyst, inactive catalyst powder particle. This catalyst has highest surface area. Later we will go that this is unstable energetically because highest surface area is exposed. And during sintering process or thermal treatment, the particle come closer together and they just aggregation is started, and we have only 4 remaining here. In this case we have all area are exposed, and after further treatment the surface areas is reduced, and the smallest surface area is spherical shape. So this is converted to some kind of spherical shape depending on the heat treatment. So it has low surface area, and this low surface area is energetically stable, and we have the spherical surface area is the lowest surface area. So this is stable, but it has its surface area is reduced, and this is not the same catalyst as we use. So this is a drawback. Later on we will discuss this. So this is the regeneration problem happen during regeneration of a catalyst.